derivatives are related to each other, you realize at the end that most reactions, I'm just repeating them, but I'm just changing the first reagent I'm using, okay? All right, so we have carboxylic acid, all right? Usually, one reaction, when they ask you, how can I get an acyl halide? How can I get an anhydride, an ester, an amide? One of the reactions would be carboxylic acid. Give it a reagent, it turns into the other ones, okay? So, the geometric shape of my carboxylic acid. How many bonds do I have in my carboxylic acid? 3. So what shape is it going to be? Trigonoplanar. So what's my angle? 120. They're definitely going to ask you about that. Okay? So, one thing about... So it does undergo nucleophilic reactions. But the difference between carboxylic acids and no, they don't undergo addition. They undergo substitution. Nucleophilic substitution. Okay? Which one undergoes nucleophilic addition? Aldehydes and my ketones. Okay, keep that in mind. They asked this for us in the final, I think. Okay, so the reactivity. I'm going to go in the order of reactivity. So I'm going to start with my acyl halides, then my anhydrides, then my esters, and then my amides. Okay, so reactivity is. Sorry, this is wrong. My reactivity decreases this way. Okay, it's supposed to be the other way. I'm going to fix that. Okay. Now for converting, I can convert my acyl halide into anything that's after it, but I cannot go the opposite way, okay? So now let's start with nomenclature of my carboxylic acids, okay? So again, just like my alkanes, just like my alcohols, if I have only one carbon, do I have to specify the position of my functional group? I don't, okay? So what we do is I grab same general rules. I grab the longest chain with my functional group. That's going to be my parent chain, okay? Now, if I have more than one carboxylic acid present, okay? What I'm going to do is I'm going to get the chain that involves both of my carboxylic acid groups, okay? I take both of them and then I start counting from each one because obviously I'm going to have substituents on both sides, right? Okay, so if you look here, I have on this side, if I start from here, I have my methyl on the second carbon. And then my ethyl on my 5th carbon. But if I go this way, my ethyl is on my 2nd carbon, and my methyl is on my 5th carbon. What would I name this?
2 ethyl. 2 ethyl. 2 ethyl.
Why?
I forgot it.
Exactly, because why? These are in the same positions. 2, 5, 2, 5, right? So in this case, I'm going to take alphabetical order into consideration, okay? Now, if I have other functional groups in my compound, I'm going to take them as normal substituents. Carboxylic acid will take the priority in the parent chain, okay? If I have a carbonyl group as a substituent, I'm going to call it oxo, okay? Know how to name it because they can give you another one saying the actual name, but we all know it's oxo, it's not the actual name, okay? A possible question they could give you, stereochemistry. Remember the not cis-trans, E and Z? They're going to give you, if they give you a name, right? They give you a compound and then they give you a bunch of names, like name this compound, right? If there's E and Z, there's a higher chance the answer is going to be the E and Z one, if stereochemistry is possible. Because they gave us a question in the final where they put E and Z, but there was no actual stereochemistry in the actual compound. There was no like up, down, or what was it called? More priority, basically. So, I did say no, if it's E and Z, there's a higher chance it's going to be an E and Z answer. But go back to the compound, look at it, see, can I make it E and Z or can I not? Okay? So, this one, memorize them. We know formaldehyde, right? Formaldehyde, its acidic form is formic acid. Acetone, its acidic form is acetic acid. Now, if I ask you, for example, true or false about carboxylic acids, right? Small number of carbons of carboxylic acids, they have distinctive smells. True or false?
True.
Think about it.
Oh, isn't this used dead bodies? Formic acid? Oh,
And
no.
acetone. Doesn't acetone have a distinctive smell?
Yes.
Exactly. This came in a question in our quiz.
But we don't have to know it now.
Can you repeat it, please?
If I ask you,
Wallah, we don't have. We don't have to know it for our quiz. It's not important.
how do you know that?
Because I asked the doctor. He said everything I didn't say it's not important.
He never mentioned that acetone has a distinctive smell.
When I asked him about the smells, he said no. I don't focus on these.
Yeah, do you mean the actual smells in the book? Yeah, that's
Yeah,
right.
the smells.
But for this one, in general, it's supposed to be general information. Same thing for us. We asked him, do we need to know the smells, the taste, stuff like that? He was like, no. But in quiz 4, they gave us a question about the smells. But this is a general idea. I didn't ask you, what does it smell like? I asked you, it has a distinctive smell. And we know acetone has a distinctive smell. So acetic acid will have a distinctive smell.
What was your question?
Okay, so in our quiz, they
Yeah.
gave us a bunch of statements about
Okay.
carboxylic acids. They asked us true or false. One of them, which most of us did not pick, was carboxylic acids with a small number of carbons have a distinctive smell.
Okay.
The answer is true. Acetone.
This acetic acid.
Yes. But it's
all
derived
the way-
from what?
From what?
What's it derived from? Acetone. Does acetone not have a smell?
Yeah.
That's basically it.
So صارت like كل واحد عنده low number of carbons طلع.
Yes, low. They said low number, but we thought of acetone, acetic acid. This is what came in our quiz, basically. Do you remember that question, or do you?
You have to know characteristics. As she said, you don't have to know the different smells, but you have to know that it has a distinctive smell. It's a characteristic. If they tell you, I don't remember how it came exactly, but when they ask you about the characteristics of a certain thing, one of the characteristics you have to know acetone is, which of the following is not a characteristic of acetone?
Okay, if they
You know,
specified and
this is how-
acetone, okay, but they said and low number of carbons, so يعني مثلا 5 low number of carbons.
No, low would be like 3 or less.
خلاص 3 or less had that distinctive.
I just pointed it out because we got it in our quiz. Don't really overthink about this point to memorize all the smells. That's not what I intended. They gave us this question. This is the only question that we were discussing after the quiz. I thought I would mention it. Okay, don't go deep into smells, stuff like that. Okay, it was just a general idea to. This is how you're supposed to link information in your brain. Okay. All right. So now we talk about the physical properties. So carboxylic acids, what bonds can they form? Hydrogen bonds. So if something can form hydrogen bonds, with soluble. Why? Because polarity is high.
Melting point. Boiling point, melting point high.
Exactly.
They can.
And I also have something called my polar dipole interaction. So that makes it even more soluble. Exactly. Okay. So comparing it with my alcohol and my ester, which is a derivative of my carboxylic acids. Okay. You see how it has the highest boiling point? Because it has two types of interactions. My hydrogen bonds and my dipole. In my alcohols, what do I have? I only have hydrogen bonds. In my esters, what do I have? Dipole only, right? But if I combine two strong forces together, I'm gonna have a double the effect, right? Okay. Now for solubility. They're more polar, like we stated there, so they're going to be more soluble. Tamam? Same thing as my alkanes, didn't we say up to 6 carbons, or my alcohols up to 6 carbon solubility decreases. Why?
They become less polar.
More hydrophobic.
More hydrophobic region.
Yeah.
More hydrophobic region, less polar, so solubility decreases. Yeah.
Why is the boiling point for carboxylic acid higher than alcohol?
Because here, I said I have two types of interactions. I have my hydrogen bonds and I have my dipole interactions. But in my alcohol, I only have my hydrogen. So it has it has one more advantage than my alcohol. So it's gonna be higher, okay? Now about the branches, same thing as my alcohols. The more the branches, higher the boiling point or lower the boiling point?
Lower.
And my solubility?
Solubility is low.
Higher
Higher.
boiling point.
Whenever we have more
The hydrophobic
No, but if it's branched, compare it to something that's like this and compare it to something that's like in one place. Okay? Now for the acidity. Okay? So when I say something is acidic, what do I mean? Donate a proton, right? Okay, so the stronger the acid, the more its ability to donate this proton, right? So some examples of strong acids would be like HI, HCl, HBr, and the ones you have commonly seen so far in this course, basically. When we're talking about acidity, we compare the stability of my anions formed from a hydrolysis reaction. Okay, hydrolysis is I'm adding water to break it down. Okay, so my alcohol. See, we're comparing alcohols and carboxylic acids. My alcohols, when I add water, I'm going to get this anion, and for my carboxylic acids, I'm going to get this anion. Why is my carboxylic acid more acidic than my alcohol? Resonance. Because if you look at the anion here, don't I still have the C double bond O? C double. Whenever I have a double bond, how it happens? Resonance, right? So resonance is gonna make resonance is gonna help it, right? Okay. Because if it has resonance here, it's gonna be more stable, so it can survive as an anion. And if I can't survive as an anion, I don't want the hydrogen. It's fine. I can live without it. So it means it is more willing to donate that proton. Okay. Everyone understood so far? Okay. Now, effect of substituents on acidity. Okay. So same thing. I think chapter 4 when you talked about electron withdrawing and electron donating groups. Okay. So same thing. The same rule used there, we're going to use it on our acids, okay? If I have an electron donating group, I'm donating. Am I going to make the bond stronger or weaker? Stronger. Do you get why?
Can you see why?
Okay, so look, think about it this way, okay? Think about electron donating groups as protein powder, okay? And I'm trying to go to the gym and become like a bodybuilder or something, right? To build my muscle, what am I going to take? Protein powder, other supplements. This is my electron donating groups, right? Okay. Now let's say I'm walking in an alleyway, مثلا. I'm just walking on the street. Somebody comes and tries to steal a bag from me. Will it be easier for them to take the bag from me? Will it be harder after I started working out and building muscle and stuff like that? Harder. Same thing here. My electron donating groups are protein, healthy stuff. Okay, they're building my muscle up. And the bond that I'm trying to break is the bag that he's trying to take away from me.
So it's something.
Exactly. So it's less acidic because acidity is what? The ability to lose the proton. Exactly. Electron withdrawing group lacks. Instead of me taking protein powder and stuff like that, I'm eating junk food. I'm not moving, being lazy. And then the same guy comes and steals the bag from me. Easier or harder? Easier, exactly. Same thing here, this becomes more acidic. And in here, if you want to explain it in chemistry terms, it's taking away the electrons. So the bond is going to be stronger or weaker? Weaker, because I'm removing the electrons, okay? Now we have two types of effects, distance and commutative effects, okay? Now for distance effect, the closer the substituent to the actual carbon, the greater the effect, right? The effect obviously depends on if the substituent is electron donating or electron withdrawing. So if I have here, for example, right, my chlorine, it's getting closer, so my acidity will increase because it's getting closer to my carbon. So if instead of the chlorine I had an electron donating group, will it become more acidic as it comes closer or less acidic? Less acidic, okay? Commutative effect, logically speaking, if I have more of the groups, more of the effect, less of the groups, less of the effects, okay? Same thing for aromatics, remember chapter 4. Electron withdrawing groups in my ortho and para positions will have a more significant effect than my meta position. So, you guys remember that or no? Blank faces when I mentioned chapter 4. When I have my groups on my ortho and my para, my electron withdrawing, it has a more significant effect than when it's on meta.
Okay, why are you mentioning this here?
Because he mentioned it.
Yeah, but I know.
No, because this is for aromatics.
How to apply it? This is aromatics. It doesn't have anything to do with شو اسمه درس carboxylic acid.
Benzoic acid.
لا benzoic acid.
Benzoic acid. Can I not have substituents on my benzoic acid?
I can, but the orthopara was with phenols, right?
It follows the same concept. Dr. Najjar didn't really go into details into this. He just stated this, Allah, as he usually does, right? So he just gives you the piece of information and you have to take it in, whether it's going to come, whether it's not going to come, whether you understand it, whether you don't understand it, you just have to keep it in mind. Because I don't know how the question could be asked, I don't know how the question could be asked, but keep it in mind, okay? You had a question? Yeah.
Benzoic acids only do meta?
No. All that I'm saying is if they have substituents, if it's in the ortho or para
That's more
position,
significant, yeah.
more significant than my meta. Okay, that's all you need to know about this. Okay, any questions? No? Okay. Okay, now to form my carboxylic acids, I'm going to add an acid and a base
To get salt.
to get a salt and water. Okay, now something we do to carboxylic acids to enhance its solubility, to make it more soluble, is we turn it into a salt. Okay, so when it turns into a salt, I have this region. This makes it even more polar, more soluble. Okay, so if they ask you, what can I do to enhance the solubility of a carboxylic acid?
Make it a salt.
And they give you different reagents, look for the base. Okay, adding a base because we know that the general equation is what? Acid and base will give me salt and water, right? So to form a salt, which is what I want to enhance solubility, I add a base. Okay. Okay, so like we said, oxidation of alcohols and aldehydes. Now,
Wait, sorry, the last part. To make the salt, what we add the base?
yes, because I already have my carboxylic acid as an acid, right? And I know that if I add an acid and a base, I'm going to get salt and water.
Yeah.
So use the same logic. If I add a base to my carboxylic acid, I'm going to get a salt and water. And this salt will be more polar than my actual acid.
Yeah.
Okay? Now, we already spoke about the first one, oxidation of alcohols and aldehydes. Okay? Now, this one, my oxidation of my aromatic alkyl side chains. So this one, I'm not targeting my benzene ring, I'm targeting my chain, right? Now for this one, you need to have at least one hydrogen on the carbon that's attached to my benzene ring, okay? We need that one hydrogen. If there is no hydrogen, the reaction will not take place. What case can I see this? My tertiary. I don't have any hydrogen in my carbon, right? It's all just R groups, صح? Because of that, if I do put the same reaction, it needs much harder conditions to occur, and when it does occur, the ring disappears, the ring breaks, it opens up, okay, and I get to a completely different compound, okay. So a question they asked was, what's the product of oxidation of a tertiary alkyl side chain on a benzene ring? I'm going to say the answer for us was it will not undergo unless under harsh conditions, okay. That's all you need to know about this one. That's for my primary and my secondary. Reaction goes normally. You just remove the whole alkyl chain, you put the carboxylic acid. Okay? Everyone got that part?
Can you show us example?
Okay, this one. Here, look. If I continue drawing, I have an H and an H, right? Okay. So this whole thing, I removed it and I added OOH, and then I had carbon dioxide. Okay? Now for my third one is we're carboxylating my Grignard reagents, okay? So basically, carboxylation is what? Carboxylation is I'm adding carbon dioxide to my reagents, okay? So here, this is the preparation of my Grignard reagent, okay? Then I have my Grignard reagent. I'm gonna add carbon dioxide, and then I'm gonna add acidic water, okay? Remember this, acidic water. I need to continue the reaction, okay? Can you see it?
Yeah.
Okay. So when I add carbon dioxide and then my acidic water, I'm going to get my whatever the R group was that was attached to my Grignard reagent. I'm just going to remove my Grignard reagent, add the COOH. Okay. Last one is hydrolysis of nitriles. This one they could ask you with how to prepare nitriles. This is a possible question. How to prepare nitriles? You get any alkyl halide, no matter what it is. You're going to add KCN. In here we have nucleophilic substitution reaction. So what's going to happen? My CN is going to go there instead of my BR. Because look, if you want to know why it's happening, my CH3 has a partial positive, by carbon actually, and my BR has a partial negative, right? And my KCN, my potassium here, it's a metal, so it's going to be a cation positive, right? And my CN is minus. So my minus is going to get attracted to my positive, and my BR, which is minus, will get attracted to my positive, but on the other side.
Yeah.
We're just switching them.
With no catalyst?
No.
طب ليش ما بضلوا stick to each other إذا positive negative؟
You
But
don't need
we're
to.
doing nucleophilic substitution, that's why.
You don't need to know why. You don't. All you need to know is this is how it happens. If it needs a catalyst, if it needs harsh conditions, don't need to know that. As far as Dr. Najjar said.
This reaction always see if is it either negative or positive or dimension?
No, if they do ask you, they'll be like, what are the reagents required for the nitride preparation? This is how they will ask you. They won't ask you, what happens. If they do, nucleophilic substitution, okay? You don't need to know details about it, okay? Then you take this nitride that you formed, you're going to add acid catalyst here, and then you're going to add water. In other words, you're just adding acidic water. So first the hydrogen will come and attack the lone pairs on the nitrogen will attack the hydrogen, okay? The hydrogen will come. Now my nitrogen has a positive charge. So then the water is gonna come and attack, and then I'm gonna get my you don't need to know what it is, you just need to know the structure.
Wait. How this became this? You say something.
What do you mean? Which one?
The CL got removed and it just joined.
Step 2 and step 3. What?
Sorry.
I think so.
Step 2 and step 3.
My carbon has 3 bonds and 1 bond, right?
Yeah.
Okay. My oxygen will come and bind to it.
To the
Okay.
C, why didn't it bind to the N, since N is the positive one? Okay, the electrons, okay.
Okay. One of the bonds here, because I can't,
No,
I'm
she's-
gonna remove it.
Mhm.
Okay. And then my O will come here, giving me an OH2. You don't really need to know, but if you go to the PowerPoint, it will show you the actual details. If you guys want
No,
to.
it doesn't show.
It doesn't show.
No.
If it doesn't show,
You don't need to know.
yes. When we're naming my acyl halide, tamam? We're naming my acyl halide. Instead of and my carboxylic acids, I ended with ic and then acid, right? My acyl halides, I just put YL and then the halide I have attached to the carbon. So it's just straightforward, right? So here I have how many carbons? 2. So it's an oil. And then the halide is Cl. This one, know its common name. Anything that's acetyl as ACE, that common name, know it, because they probably will ask you about it. Okay? Same thing for here. Look, here we have 2 halides, but which one am I going to mention as the halide at the end?
The CL.
The Cl, because my Br is not bonded to my carbon and carbon, right? So this one I'm gonna act like I'm normally naming it. So here I have 3 carbons, right? So propanoil, and then I have my Br at the first carbon or my third carbon? Third carbon, because this is always my first carbon. Yes.
Why is the bromine first? Is it because the alphabetical order?
What do you mean first? And why didn't we put it as the last name?
Yeah.
Okay. The halide that you put has to be bonded to the C double bond O.
Okay.
My bromine here is not part of my actual carbon in here. It's on the side. As my Cl here is actually bonded to it, so I name it at the end. Okay? These common names, you don't really need to know them. Just anything with ACE, he's probably going to ask you. The doctor's probably going to ask you about it. Okay, now to prepare it, okay, again, we start with my carboxylic acid. We add SOCl2, and then we add either HCl or SO2. Okay? We're going to do you need to know how the reaction is actually taking place? No. You just need to know what I need to add, and what I need to add to what, and then what I get. Okay? Don't go into the details of the arrows and the. Okay?
We should go to it.
No, you don't really need to go into the details.
Yeah, because it's really a lot of reactions. If you want to memorize all of these, it's impossible to memorize all of these. We have to understand them.
But I told you, as I go on, you're gonna see the most reactions are repeating themselves. Because some of the reactions they undergo are exactly the same. They even end up with the same product. It's just we're starting with a different reagent in the beginning. Okay. Okay. Now this reaction, the doctor did mention it for us. Whenever I react an acid with an alcohol to form an ester, I only need room temperature. I don't need the catalyst. Okay, no catalyst is needed. This reaction happens. Okay.
Ester with water, right? With water.
Yes. Okay, now how to prepare my acid halides. First of all, it's my hydrolysis. In this case, I don't need an acid. Okay, I don't need a catalyst basically. Okay, so I just add water. I'm going to get my carboxylic acid. Okay, and then I'm gonna get my HCl. Okay, don't tell me and no, I can do the opposite reaction to get my acid halide. That's not one of the that's not how we prepare it. Remember how we prepare it? This reverse reaction, no. Okay, don't try to make your own conclusions from this, okay? Ammonolysis, which is basically I'm just adding an ammonia group. Okay, I'm adding an ammonia group. What happens? It acts as a nucleophile, it attacks my carbon, and it gets me this NH. What is this called? Amides, which we're going to talk about at the end. Now, we can use an acid halide to form an anhydride. Why can I do that? What's the reasoning behind me being able to form an anhydride from an acid halide?
Because acid halide is
more reactive. It's more reactive, okay? So an acid halide will react with the salt of the acid and gives the anhydride, okay? So this process is actually 2 steps. Addition, بعدين elimination. So first we start by adding and then we eliminate, okay? So this is the overall reaction, okay?
So you add and then you remove, so it's substitution.
It is substitution, but if he could ask you what reactions take place during the substitution reaction, first we add and then we eliminate, okay? Not the opposite. We add and then we eliminate. That's it for my acid halides. So far, pretty straightforward. So any questions about this one? Okay. Now we go to my acid anhydride, okay? To name it, I keep the oic, I just remove the acid and put anhydride, okay? So if I have the same groups on both sides, I don't need to put diethanoic anhydride. Okay, I can just put ethanoic anhydride or propanoic anhydride. Okay, I don't need to put ethanoic anhydride or diethanoic anhydride. This common name, again, ACE, memorize it, okay? Here, since it's unsymmetric, right? So obviously I'm going to mention both sides, okay? On one side I have butan, focus 4, butanoic, and then on one side I have ethanoic. So here I use the alphabetical order, so it's butanoic, ethanoic, anhydride, okay? Now how to prepare it, I think it's only 2 reactions, okay? We dehydrate 2 alcohols, 2 acids, okay? Which makes sense if you look at the structure here. Doesn't it look like I got 2 acids and I merged them together? So we're gonna dehydrate it, so we're gonna remove a water. We need here an acid catalyst and heat, okay? This needs a dehydrating agent, so here you need to check if there's a catalyst mentioned or not, and if the catalyst is a dehydrating agent. Usually, he's only going to put H2SO4. They won't really go into the other ones, but make sure there is an agent there, okay? So we're going to get my anhydride, and then I'm going to get my water, okay? My second way is my acid halide, which I just spoke about, reacts with a salt to give me anhydride, okay? The salt is a salt of what? Salt of a carboxylic acid, okay? It reacts with the salt, and then it's going to give me my, here, see? 2 R groups, and then 2 double bonds, and then NaCl. Afo?
I didn't get to B.
B? Okay. What's your question?
Just butanoic, ethanoic, anhydride. Is it the common name or the
IUPAC. Only common name for this that the doctor mentioned for us was acetic anhydride, unless he mentioned other ones for you. Whatever the doctor mentions is common.
في formic anhydride ولا مستحيل؟ لا في.
Could be, but he didn't mention it for us.
I mean, can we have methyl يعني methyl مع methyl?
You mean one carbon?
إذا اسمه anhydride, yes.
Yeah, I think it's possible. If you have one carbon.
إذا اسمه anhydride.
Yeah, because anhydride is the fact that you have OOO.
Okay.
Okay? But wait, no. Yes, formid, because you have one carbon here, so technically it would be formid. You get what I'm trying to say?
Yeah.
So it could be, yes.
Formic anhydride.
Formic anhydride could be possible. Did he mention it for you guys?
I can't remember.
Whatever, this is what you see. You have to remember what he mentions. Because he asks about what he mentions.
Can you repeat part B?
Yeah, I'm gonna repeat properly. Okay, so I get my acid halide. You know the one we were talking about? This one. My acid halide was right here. This one. This will react with the salt. When I say salt, it means I have a compound and then I have Na plus binded to it, okay? it will react with the acid of the salt of my carboxylic acid. See, if you look at here, I have, instead of the Na, if I put H, what would I have?
Carboxylic acid.
Carboxylic acid. So this is the salt of my carboxylic acid. It will react with my acid halide to give me my anhydride.
For it to become a salt, does it have to be Na or can it be any metal?
I'm not really sure about that, but the examples that will be given for you would be Na.
Yeah, because salts usually it's a group 1 or group 2 metal.
Yes.
So maybe K as well.
Yeah, but he won't. They don't really go into that, especially the book. If it's not mentioned, it's not going to be there. Okay. Everyone
You
understands.
said something about AEC. What is it?
ACE, I said any common name you find in the
Acetic,
PowerPoint, in the
acetic.
book, yeah, just ACE, and because it could be acetic anhydride, anything that starts with ACE, the
Okay.
common name, memorize it. Same thing for formaldehyde and stuff like that. You need to know what they mean because they could show you the compound and ask you for the common name, and then you have to put that instead of the actual IUPAC name. Okay. Everything okay so far? Okay. For the reactions, okay? So for reactions, you have to know LiAlH4. This reaction, what can we call this reaction?
Reduction.
Reduction reaction. So it's the opposite of oxidation, okay? So basically, so what happens is, so my LiAlH4, so one of the hydrogens will come and attack the carbon, okay? It attacks one of the carbons, and then this bond has what? Electrons, right? So the electrons will go to the oxygen, giving my oxygen a negative charge, okay? So now I have an oxygen with a negative charge, and my carbon has 4 bonds. But now my oxygen doesn't want to keep the negative charge, right? So the negative charge will come back to form a double bond. But now my carbon has what? 5 bonds if it forms the double bond, right? If it forms, so what happens? This bond between my carbon and my oxygen will break. So now what do I have? I have my aldehyde, okay? So that's this reaction. If they give you 2 moles of LiAlH4, my reaction will continue to give me my primary alcohol, right? Because we know that primary alcohol oxidize it to something, it's going to give me aldehyde. So if I do the opposite, exactly. So same thing as that happened there. The H will come and attack the carbon, negative charge on the oxygen, and then I'm going to have my primary alcohol. Okay?
So in the quiz, if we see يعني بس 1 mole
Yes.
أو without 2 يعني بس حاط لنا LiAlH4, do you consider it يعني only one step reaction يعني بس لحط الالدهايد without?
This is what the doctor mentioned for us. He was like, if you see 1 or no number, the answer should be aldehyde, but make sure with your doctor on this one. Because he can change it, like in spring, he changed it. Depends on the doctor basically, okay? So do check with the doctor. But this is what he mentioned for us. Yes, okay? Because he's the one who makes the exams at the end of the day, okay? He's the coordinator of chemistry 1. Now, second reaction, Grignard reagent. What was the similar reaction?
Formation.
Acid halide, didn't they also react with my Grignard reagent?
Yeah.
صح ولا لا? Do you
Can
guys
you show
remember?
us?
Yes.
Show us? I'll show you. نرجع.
If you
Why do you
ask
actually-
him, then what he says
Okay.
about this.
For my, where is that? Where is it? Here for my carboxylic acids. We had the Grignard reagent, right? So now my anhydride will undergo my Grignard reagent, okay? For Grignard reagent, we're first going to get a ketone, and then we're going to get a tertiary alcohol, okay? So same thing here. As any Grignard reaction takes place, same steps, okay? Just know that first you get a ketone, and then you get tertiary alcohol. So when they ask you reduction of anhydrides, what do they give you? Primary alcohol. Grignard reagent, tertiary alcohol, okay? Don't get them mixed up, okay? Okay. Now for number 3, which is addition of water and alcohol, okay? So we can add both water and alcohol. In other words, when I add the water, what do I mean? Hydrolysis. Same thing with alcohol, it's going to give me a hydrolysis reaction. When we do alcohol, I'm going to get an ester. Why? I'm gonna get an ester instead of just here. So look, see at the water one? This is my anhydride, right? Reacted with the water, it gave me carboxylic acid, right? But why is it with my alcohol I got
Alcohol
Because I
Carboxylic
think the
acid.
carboxylic acid maybe it affects the
because there's an R group on the
yeah,
OH.
the R group on the
Okay? The R group makes a
I don't
difference
get
here.
that part.
Water, do I have any R groups attached to it? No. So it's just gonna break and that's it.
This is carboxylic
When water?
acid.
Here, water here.
I'm saying no, first step. You're talking about first step.
No, I'm talking about, no, this is alcohol, this is water.
She's asking about the first step. And
Yeah, I'm explaining it to her and what's the difference? Why am I getting only carboxylic acids with my water and why am I getting ester and carboxylic acid in my other one, right? And no, my alcohol does have the OH but it has an R group, okay? So now aren't we gonna break it like here with water? Aren't we gonna break it here, right? Or usually the H will go to the side with the O and the OH will go to the side with no O, right? In the case of alcohol, I don't have just an H, I have an R group, right? And if I add the R group, see here, like if you look here, I broke it here. The O will have an H, so I got a carboxylic acid. Life's good, right? But for my other side, I added a CH3, an OCH3.
so these are two reactions. One with alcohol and the other one with water.
Yeah, no, two different reactions, I'm saying.
The first one with alcohol and the second one
Yes.
with alcohol.
If it was asymmetric.
Hmm?
If it was asymmetric.
If it was, for this one, if it was asymmetric, you'll have two different carboxylic acids.
The two carboxylic acids.
Okay, but for this one, yeah, it depends on where you break it. The products depend on where you break it.
Or if it was asymmetric, do we have a major and a minor or?
Don't need to know that. You don't need to know that. Okay. Last one, ammonia. We already mentioned ammonolysis, right? Ammonia. So we're gonna add ammonia to my anhydride to form my amide. No, and when you add ammonia, you form an amide. Okay. Okay. You see how now it's the same reaction technically, and they get the same product. This is what I mean at the end, and you don't really need to memorize every single reaction. You just need to know the idea of one, and then incorporate it into the others. Okay. So did everyone get this part?
Yes.
Okay. Esters now. You see what I meant with the alcohol parts? And when I add an alcohol, I'm adding an R group forming an ester. Do you understand that?
Yeah,
Yes?
yes.
Okay. Okay, now for my general formula, R C double bond O O R. Okay, instead of the H in my carboxylic acid, I have an R. Okay, these things you have to know. Okay, they can ask you about these things. Okay, so they're highly abundant in nature. They're characterized by a good smell. Same shape, it's trigonoplanar, 120 degrees. It has a lower boiling point than acids. Why? No hydrogen bonds here. It only has my dipole-dipole interactions. Okay, but it's still soluble because of the polarity. Okay, but it's usually less than my carboxylic acid. Okay. Now for my nomenclature, here you divide it into two parts. Okay. One part will give me my acid and one part will give me my alcohol. How do I know that? Wherever they divide it, if it has C double bond O, obviously this isn't going to be my alkyl group, logically speaking, right? Because it has my COO, right? The other side has nothing, so it's going to be my alkyl group, alright? So for this one, I will name it my ethyl and then ethanoid. I put my alkyl and then I put my acid derivative, basically, okay? Now, sometimes you can have the benzene ring act as, again, a substituent, not an actual part of the functional group, right? In this case, I can call it benzoate, or for the common name, I can put benzene, okay? So here it would be methyl benzoate, okay? So when benzoic acid is treated as a substituent, I can call it benzoate, or I can just say benzene carboxylate. Why? This is the only case where you can call it carboxylate here, because there's only a methyl group here. There's only one carbon. If I had 3 carbons here, I can't say carboxylate. صح ولا لا? Logically speaking, right?
What is carboxylate?
Carboxylate is when I have only 1 carbon.
When I have?
1 carbon.
Okay.
Because carboxylate, I'm talking about 1. But if I had 3 methyl, I can't use carboxylate here.
If we had 3, what would they call it?
Here you would name it this way.
Benzene ring, okay, is attached to carboxylate group.
Look, here in this case, isn't this technically benzoic acid.
Yes.
So if it here,
But benzoic acid with شو اسمه methyl.
okay, but now I'm naming it as an ester, right? This part is going to be my alkyl group, and this part is going to be my part derived from the acid.
I got the
Okay.
first one, methyl benzoic, but the second one.
This one has a special case for this one.
What is it?
Just this one.
شو هي carboxylate؟
Carboxylate is the methyl here.
طب حطينا البنزين مع الميثيل، طب واللي بالنص شو؟ تبع الاوكسيد.
This is a common name.
طب خلاص هي common name؟
Yes, it's not. IUPAC name is IUPAC. You follow this. You follow the alkyl and then the.
Systematic.
Okay, but this one the doctor mentioned, so just a common name. It's the only case where it's like this. Okay, it's a special. It's a really special
If
case.
we had like 2 carbons, it will not work.
Then you name it IUPAC. You give it the IUPAC name. Okay, so only when you see carboxylate, you're gonna know على طول إنه it's a common name. It's not an IUPAC name. Okay, clear with this part?
Yep.
Okay. Okay, now how to prepare it? Okay, so one type preparation would be acid and alcohol. Because if you look at it from this way, I already have an acid, right? I can get this part from an alcohol, right? So I'm going to put an acid. I'm going to put an alcohol. Okay. This bond will be broken. This bond will be broken. They bind together, and then they'll give me my ester. صح? Does everyone?
ما هلا قلنا
Hmm?
Didn't we discuss it?
Which what?
This reaction.
This reaction? Yeah, the other one.
Yeah, the same.
Yes,
It's
yes.
the same.
Yes. Okay. So this is what happens. Okay. Now here I need an acid catalyst. This reaction will not go unless I have an acid catalyst, because alcohol here is not a strong nucleophile. Okay. I need to prepare the compound for the alcohol. Okay. The alcohol is insan miskin. He needs help. Okay. So what happens so basically I'm gonna add my acid. So my proton here will come and attack the oxygen on my carbon here. It gets protonated. I'm gonna have a carbocation form. Okay. This carbocation now it's more than ready to receive anything, right? So in this case now it's better. My alcohol will come. The lone pair of my oxygen will come and attack my carbocation. Okay, giving me this beautiful structure right here. Okay. Now when my oxygen here will come and form a bond with my carbon, right? صح ولا لا?
Yes.
Okay, but now my oxygen has 3 bonds, right? So now I want to get rid of the 3rd bond. So what do? One of the H's will leave, right? The H here will come and attack the OH here.
Okay, so
معاي ولا مش معاي؟
Yeah.
Okay?
Remove it as water.
Yes, I'm trying to remove the water because so now I can have my
Double bonds.
exactly. So here, look, it's gonna come and attack here. So now I just moved it from here to here. Okay? Do you guys see what happened? فاهمين ولا مش فاهم؟ Okay, فاهمين? So then I have my carbon here. Now I still want to, and my ester doesn't it have a double bond?
Yep.
Yes.
Okay, so I want the double bond back, right? So I'm going to, here I'm going to form a double bond, here I'm going to form a double bond. Sorry, here I'm going to, yeah. No, sorry, here I'm going to form a double bond. Sorry, here I'm going to form a double bond, and here I'm going to remove the extra bond that I have.
Yeah, so you get the H plus and the water.
Exactly, so now I'm going to end up with a water molecule, H plus, and my ester.
Why does the H attack the OH on the top? Why not the OH next to it? Does it not change anything?
It will, but eventually. I think the book mentioned something about it can attack either.
It can attack either, but in this
Equal.
case, I just used that one.
Okay, so just no difference.
Yes, it just attacks another OH found on that group, okay? So this is the same reaction as my anhydrous and my acid halides, okay? So, makes sense?
في سؤال بيدخل على steps.
We never got asked about these steps, as far as I remember. You just need to know the general idea, and you need to know that you need an acid catalyst, and why you need an acid catalyst here.
من وين جايبين هاي الستبس بالكتاب؟
Doctor,
دكتور؟
yes.
Why do we need
They
acid
don't come
catalyst?
in the.
Why do I told you we need my alcohol is not a strong nucleophile. I need to help it. So how do I help it? I add the acid catalyst to prepare my actual carboxylic acid to make it like weaker. To make it now, because I have the positive charge now, it wants to form a bond. Okay?
Yes, in the book it says it doesn't matter which OH.
Yeah, which one doesn't matter. It's an OH at the end of the day. Okay? Understood this part? Okay.
room temperature, right?
Yes, but they focus on the acid catalyst. If they ask you a question, they ask you about the acid catalyst. Now we have something called lactones. Lactones is just a cyclic ester. So the ester was straight, we just لفيناها, okay? So this only takes place, usually this takes place with 5 or 6 membered rings. Now you ask me why, I don't know. The doctor said that, okay?
Something related to
It's probably related to steric strain, if you remember from chapter 3, I think. 2. Steric strain, yes, okay? So usually if you have a 5 or 6 membered ring and you need to have 2 functional groups, acid and alcohol, okay? If they don't have the 2 functional groups, no cyclization, okay? So this is the overall. See, I had my carboxylic acid, I had my alcohol. It will come and attack my other functional group, right? It's gonna form this. You don't really need to know the details, just know and know I need. Yes, sorry.
Do we need a catalyst here, or does it happen by itself?
But I don't think the doctor mentioned it. I'm not sure. Did the doctor mention anything about this?
والله بالباوربوينت في catalyst.
Fee? Okay, so
Yeah.
then there's a catalyst.
Yeah, H plus or heat or
Okay.
أول هذه أوري.
بالكتاب.
Okay. So here you will use a catalyst. Okay. But always remember 2 functional groups, 5 or 6 membered rings. You just تطويها على بعضهم.
It's always those 2 functional groups.
Yes. For this for lactones, yes. Yeah. Okay. So everyone understood this part?
Yep.
Okay. Now the reactions that it undergoes. So hydrolysis. In this case, I can't use water alone. In my other reactions, I was easily able to use water, right? Here, I need a catalyst. My catalyst could either be acidic or basic, okay? In the case of it being an acid, okay, as we know from before from our reactions, when we add the acid catalyst, it follows the same flow basically, okay? So we add the H. The H will come and attack my oxygen, okay? Come and attack my oxygen, okay? And then this is a reverse. You don't really need to know if it's reversible, non-reversible. The doctor doesn't go into those details, but you need to know you have 2 catalysts, acid and base, and the products in both cases will be my acid and my alcohol.
When the hydrogen attacks the oxygen, ما لازم تروح وحدة البونز double bonds.
Oh, this is intermediate. Intermediate is formed. Here there's a lot of intermediates.
وحدة النوع pairs of the
Yes, this is a lot of, you don't need to know, again, you don't need to know in details, but when the hydrogen comes and attacks, bondings will, electrons will move from here to here, but again, you don't really need to know them deeply into details, but know the general idea of what's happening basically, okay?
I have a question.
Yes.
Products R1 or Atlish R1 نشوف R2.
It could be R1 or R2.
Does it matter?
Here, see here, it can't be R1 or R2, because look here. If I break it, here I'm breaking it, okay? I'm breaking it with water. It could be R1 here or R2, but it depends on where they break it, okay? They could give you products with different alcohols, but you just need to know which one is the actual product form. So in these questions, right, they could give you an actual equation, and then they could give you products. For example, I started with 6 carbons in my reagent, and one of the products they gave me in total has 7 carbons. Technically, that's impossible, right? Where did we get the other carbons from? So it could be R1 OH or R2 OH, depends on where you're breaking it. You have to check and make sure what they put makes sense according to the actual reagent they gave you, okay? Now everyone understood the acidic part? Okay, now for my basic part, we call this saponification. Okay, we're forming soaps basically, okay? So here my OH will come and attack, okay? It will attack here, and then my double bond here will be broken, okay? It will give me this carbon with an O minus, so in the second step, this part will be broken, okay? This part will be broken, giving me this chain with O, which will go and attack the thing I formed already.
The OH, yeah.
Do you guys understand what I said? Okay, so Anna, didn't I break it here? I broke it here, right? And I formed this product, right? This is gonna come and attack it back.
The hydrogen.
The alcohol, isn't this gonna form an alcohol?
Yeah.
صح? Right, so the alcohol ion basically is gonna come and attack my carboxylic acid that was formed. Because
Just
I
grab
remember
a
when we
hydrogen.
had the
It will grab a hydrogen.
yes, and when we have a basic catalyst, didn't we say we add acid at the end?
Yeah.
صح? So the acid then will come and it will do the sorry, will come and give its edge to my carboxylic acid, okay? But you just need to know, and the alcohol here will attack, okay? He didn't go into details in this for us, but yeah, okay. So here for this one, okay? Sorry, yeah.
Go back, please. The carboxylic acid without the H, is it stable? Because there's a minus on the O. This one here.
Another step will take place where you add an acid, or acidic water, basically. Okay, you're going to add and it will continue the reaction. Okay, but the final product is an acid and an alcohol. Okay, so for saponification, basically, they could give you a structure that looks really big and bulky. All you have to do in this case, whenever you have this C double bond O, the bond right next to it, you're just gonna break it. Okay, you're gonna break it, and then this is okay. So one part will get Na because we're adding a base, right? It's the same concept as the other one. You know, I added the base to begin with, okay? So one side will get my OH, which is this side. The side with the, sorry, yeah, this, okay? And then the other side will get my Na, okay? So you saw what happened?
Well, can this work if we just had an acid instead of a base? Or this is always for bases?
This is specifically for a basic catalyst. This saponification is when you have a basic catalyst. Okay? One side will get the Na, which is this side, and then this one will get my OH to give me an alcohol. Okay, so in this, for example, for this one, this is glycerol. Okay? Understood this part? So we see my carbonyl group and my O, we break it here, and then we move on. Okay? And then the other one, you just put the Na beside the O, and that's it. You don't need to know the name, you just need to know that that is the soap that I'm forming. Okay, everyone understood this part? Okay. Now, again, we're adding ammonia. When I add ammonia, what do I get? Amide. شوف تكرار, we're repeating, okay? So we're gonna get an amide, and then we're going to get an alcohol here, because, okay? Here, same thing, we also use the same concept as what? Seeing the carbon double bond O and the O, and then just breaking the bond. Same thing here. I saw the carbon double bond O and the O, I broke it here. That's all I did, basically. Okay?
You mean you broke it with the C? That side. The C and O.
Yeah,
Yeah,
this
okay.
one. Okay? To form the alcohol, sorry. Okay? Third reaction is the Grignard reagent. This is the same thing as my aldehydes and ketones, which my colleague Farah will be explaining. Okay? Here, first a ketone is formed, and then
Alcohol.
tertiary alcohol is formed. Okay, this one you need to know. Okay, everyone understood the reactions? Everyone understood the reactions? Okay. When we reduce, we have usually two things that can reduce, either NABH4 or LiAlH4. In the case of esters, I can only reduce it with LiAlH4. I cannot do it with NABH4. Before you ask me why, I don't know. But that's what the doctor mentioned, that's what we need to know. That NABH4 cannot be used for the acid and their derivatives, all of them. So carboxylic acid and all of them, okay? The final product is either an aldehyde or a primary alcohol. Here, same thing. You see the number of moles. If it's 1 mole, if it's 2 moles, okay? So if it's 1 mole, it will be aldehyde, 2 moles, it will give me primary alcohol. But again, check with Dr. Najjar if this really matters or not, okay?
Wait, can I go back?
Yes.
Sam, after the first hydrogen attack,
Mm-hmm.
the aldehyde, what would be the leaving group?
The leaving group?
Yep.
There is the O here. Same thing. You see how here we attack the carbonyl group? And we got an aldehyde. Aldehyde has a carbonyl group, so the hydrogen will come and attack the carbonyl group.
And the O
And then the O will get the negative charge. Here, this one and this one mean the same thing.
Okay, okay.
Okay, just to show you a note, it's the same thing, same reaction, but just happens twice. The carbonyl group gets attacked by the hydrogen, giving me an aldehyde, and then the carbonyl group, I still have a carbonyl group, right? The hydrogen will come and attack my carbonyl group, same thing as here. It's the same reaction twice, same exact steps. Okay, everyone understood this part? Okay. Now the last one, which is amides. Okay, so a reaction where we could form amides is my ester and ammonia. Okay, see, we're repeating ourselves. It's that they're all linked to each other in a certain way. Okay, then how do I name them? My primary is just the group name and then the amide. Okay, simple as that. Okay, my secondary, I act as if it's a substituent basically. So here, look, this is my N, right? If I have one substituent, I'd be like N methyl, N propyl, N phenyl, N whatever it is. Okay, but if I have two substituents, okay, NN. If it's on the same, if it's the same substituent, it's gonna be NN. Like for example, if I have two chlorine and one carbon, I'm just gonna put one chloro. So same thing here. I'm gonna put NN dimethyl or dichloro. Sorry. Okay. And this is the secondary one because I have one hydrogen left, right? This one here, it's a tertiary because I have no hydrogen. Okay. Ever understood this part with the naming?
Does it have a common name?
The doctor didn't mention any common names other than isopropanoic acid. That's all he mentioned. For amides, he did not mention any common name for us. I don't know if he mentioned any common names for you guys, did he? No? But he didn't mention any amides, because he didn't mention any amides for us. Common names at least. Okay?
We did it chapter 11 with 11. Yeah, chapter 11.
Okay, now for the solubility of my primary and my secondary, okay? Now, my tertiary is way less soluble than my primary and my secondary. Way less soluble, okay? Why?
There are common names.
There are? So those mentioned in the PowerPoint?
In the PowerPoint.
Then memorize those common names, okay?
This, the mashallah.
Sometimes they mention things besides that.
Wait, show me. Maybe he said in another fatwa.
Yeah, so guys, did he mention that you have to memorize them?
Oh yeah.
He mentioned them?
Yeah,
Okay,
yeah,
if he
yeah.
mentioned, then you have to memorize them, okay? Because I remember for us, we did not have
We
any,
didn't.
we didn't have, okay.
Okay.
You snooze, you lose. Okay, so for my amides, my primary and my secondary can form hydrogen bonds. Okay, hydrogen bonds, more solubility, right? Higher solubility. My tertiary miskin, he doesn't have any hydrogens, so he can't form those hydrogen bonds. So solubility is way less compared to my secondary and my primary. Here, my secondary is less soluble than my primary because this forms two double bonds and this forms one double bond. Okay. All right. So why don't we consider an amide a base like ammonia?
An electron is what determines if it's a base or not.
Mhm.
It's like going to the oxygen.
Exactly. Why? Due to
Electronegativity of oxygen.
resonance. Resonance. Okay, because it's busy in resonance.
Can you repeat what you said?
I asked, and ammonia is considered the base, but why can I not consider amide as a base? The reason for that, just like they said, I do have a lone pair, right? But my lone pair is busy doing resonance. Here's how the resonance is taking place, okay? Oh, sorry, no, I didn't write it. Mhm. So this lone pair that's on my nitrogen is busy doing resonance. And if it's already busy doing something else, can it be busy doing something else? No, it's already busy doing resonance, which is like hard work and stuff, right? So it's not going to be able to act as an actual base. So that's why we don't consider amides.
Isn't it supposed to be basic? Like overall, it is basic. Not as basic as ammonia.
Yeah, but it doesn't. We don't consider it a base. Like if I give you or give me a basic catalyst, you're not going to tell me here's an amide. صح ولا لا?
I'm not sure. Is it acidic?
It's not acidic, no. But it's just saying why did we compare it to ammonia? Because ammonia is NH3, right? Ammonia is NH3, but this is NH2. But why can I not consider this to be a base? Because my lone pair here, it's busy. It's not going to help me with any other reaction. It's already doing something. It can't multitask. you get that part? You sure?
But like,
So just all you need to know for secondary and tertiary, the number of this matters. If they give you 1, I'm going to have a secondary. If they give you 2, I'm going to have tertiary, okay? That's it, okay? Now for the reactions, my amides are my least reactive, okay? They're my least reactive out of my acid derivatives because the amide bond here is really important for life. Where can you find these? Amino acids and proteins, okay? Imagine if the bond was really weak in my amino acids. We wouldn't be alive. My DNA is made of, my protein is made of amino acids, right? If they keep breaking, how am I going to survive as a human being or as a creature, okay? But the reactions it does undergo is hydrolysis. Hydrolysis with water and then heat, okay? When I break it down, I'm going to get what? My starting point, my carboxylic acid. Usually when you're hydrolyzing it, you get my starting point, my carboxylic acid, and then ammonia, okay? Then my Grignard's reagent, this happens 2 times like in all the other times it happened. It always undergoes, it happens twice, tamam? Here, good? Here we got, again, what do we get when I'm doing my Grignard reagent? Tertiary alcohol. صح ولا لا؟ صح, okay? Then the last one is the reduction by LiAlH4. Why can't I use NABH4?
It's not strong enough.
Exactly, okay? Here my product is going to be an amine. I'm going to add the LiAlH4 and then I'm going to add acidic water to give me my amine, okay? I cannot do the opposite here. I cannot oxidize an amine to give me an amide. The reaction is not, it's going to give me something else. It's not going to give me an amide, okay? So I don't do the opposite. Like I said, if the reaction is not clearly stated, and you can go in opposite directions, don't assume they can go in opposite directions, okay?
I have a question. Hydrolysis.
Yes.
Can we start with an ester?
Where?
No, like to prepare amides, we start with an ester.
Yeah, but what did we add?
Ammonia.
We didn't start with an ester, we started with carboxylic acid. Hydrolysis, I'm breaking it down apart. Okay, I'm adding water. I'm not adding any nitrogen. So, logically speaking, if I'm not adding nitrogen, am I going to get an amide somehow? From just hydrolysis. I'm just adding water. Okay? So okay? So, here for my hydrolysis, I'm breaking this. I decided to break it. I'm going to get my carboxylic acid and I'm going to get my ammonia, which is the opposite of which reaction?
Preparation.
Okay? Chapter 10. Yes.
If we add the MgX 2 times, we get a tertiary?
Yes.
Okay, and what if we do it 1 time, we get
Same thing as the other reactions.
secondary?
Not secondary, no.
I forgot.
You mentioned it before.
And no, if we're adding the RMgX 2 times, we're getting a tertiary.
No, not this one, sorry. Where is it? Ketone.
Oh, yeah.
But for the other reaction, this is what I'm saying, these alcohols, know which one is which. Differentiate between them, don't mix up between them, okay?
I just answered it, but to look at the other R.
So is chapter 10 clear?
Yes, it's okay, it's confusing to me. It's a lot of...
No more questions for chapter 10? Did you see how at the end I'm just repeating reactions? Okay, so I'm gonna pass the mic to Farah. Good luck on your exam. Thank you.
How do I
Just put it in your pocket and then this mic. Okay, perfect.
Hi guys.
Hi. Hello.
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 Okay, so we're gonna start with chapter 9. I'll try to make it as short and simple as possible. Again, just a disclaimer, this is a revision, so of course you still need to study on your own through, I recommend Dr. Najjar's slides, personally. I studied from that, and I'll give you a little life hack in the end. So for aldehydes and ketones, what makes them, what keeps them in common, and what they have in common is the carbonyl group. So aldehydes have at least one H attached to the carbonyl carbon, and ketones have two carbons attached to the carbonyl carbon. Okay, this is clear, right? So for naming, I think you guys have been experts in naming now, right? Probably. So I'll go through it if I see that you guys cannot, but can you name this for me? This is for aldehydes.
2-methyl-pentanal.
Yes. 2-methyl-pentanal. Does everyone agree?
I don't have to go through naming.
Maybe for the YouTube guys ما عم تصوروا؟
We are.
بلكي هن بدهم يفهموا.
كان لازم شيء يحضر.
كان لازم يحضروا. What is this? They're missing out. Yes. So for common names for aldehydes, you just have to know these. So methanal is formaldehyde, ethanal is acetaldehyde, propanal, propionaldehyde, and so on. You just have to memorize this. Memorize. Naming ketones. ما راح نعيدها للجايز اللي ما حضروا يعني we can't do anything. So can you name this?
4-methyl heptano 2-heptano 4-methyl 2-heptano
4-methyl
2-heptanol.
2-heptanone. Yes. Or heptatone. I think it's possible to. Yes. So also common names of ketones. Again, for ketones, it's usually because of the number of carbons. This is the common name for it. So dimethyl ketone is propanone or even acetone. So you need to know these.
I have
Just
a
go.
question. I think for 4 carbons we don't write the number, right?
Which one?
2-butanol. We don't mention the number. It's just with butanol. What?
صح I got this question while studying. I was confused ليه حطيناها.
لا بنحطه اجباري لو اوكي
It's a
بدي
ketone. لو
It's a
aldehyde, we
ketone.
have to.
Yeah. I don't know why the doctor put it.
My mistake.
لا, even the book put it. هيك الكتاب.
Yeah, just then memorize that. Take it as it is. I'm not sure honestly. I agree with you. It's logical يعني and no, it's just butanol. I actually don't know. So just get one. Physical properties, I'll go through them quickly. Boiling points, intermediate between alcohols and alkanes. For polarity, both compounds are polar due to the difference of electronegativity between C and O. We understand this? Yeah. Ketones are more polar than aldehydes due to the inductive effect. We all understand what the inductive effect is? Okay.
What is inductive effect?
Because the ketone has carbons, like 2 carbons, so they kind of like push towards the O, so the O becomes more attractive. You get me? There's more polarity because there is the O becomes more negative and the C becomes more positive because of it has extra C's. For the aldehydes, they have an H. They only have 1 C, so it's not as strong as the ketone. You got it?
Yes.
Okay. For solubility, smaller compounds are soluble in water as they are H bond acceptors. Clear. Solubility decreases as number of carbons decreases. It's also clear, right? Very clear. Okay, so common aldehydes or ketones, you need to know these. For formaldehyde, you need to know everything here. So formaldehyde is used as a starting material for other chemicals and as a disinfectant or preservative. Acetaldehyde is used as starting material for other chemicals and to make acetic acid. Acetone is used as a starting material for other chemicals and as a solvent. Just memorize these. Most of the things.
So we have now ethers and water and acetone can be solvents.
Yeah.
Or all ketones can be solvents.
These are just common aldehydes and their uses. If they ask you about these, they're usually about the usage of one of them, and it's just.
Yeah, I mean only acetone between the ketones act as a solvent, not all the ketones, right?
I think so, but I think it's the most common one. It's commonly used.
Yeah.
I'm not sure if the other ones are used. So synthesis of aldehydes and ketones. Aldehydes and ketones are commonly synthesized from an alcohol by oxidation. I think you discussed this with Malak, and I saw that you guys know this already. So you know that the alcohol it gives us an aldehyde, and it can also give us a carboxylic acid if it's not what's it called? Yes. So Jones reagent oxidizes primary to an acid and secondary alcohol to a ketone. You know this? Okay. PCC oxidizes primary alcohol to an aldehyde. I feel like most of the things we're gonna discuss is just you memorizing it on your own. I'm just gonna highlight the important things that you need to focus on.
tertiary alcohols cannot be oxidized. This is a very key thing to know, and I think by now you probably know it. It's very, very important. The questions sometimes they trick you by using this piece of information, so you really need to know this, okay? So aromatic ketones can be prepared by the Friedel-Crafts acylation reactions, and methyl ketones can be prepared from terminal alkynes. Blindly memorized, yes.
Can PCC oxidize secondary alcohols?
Yes.
Yes, it does. Yes, but just the idea is that it's Wait. Yes, it does. I think it does.
So we can use both Jones reagent and PCC?
Yeah. By the way, for oxidizing agents, it's not only PCC. It's just why he said PCC in particular. It's the most commonly used for this reaction. But all of them, K2CR207 is used with H plus. KMNO4 is used. All of them are oxidizing agents that are used, but there are ones that are stronger than others, and there are ones that are commonly used for certain ones. You get me?
Yeah.
So they all oxidize. وعلى فكرة, for aldehydes, if you don't, I forgot what it's called. I forgot the term for it. But if you don't avoid the escape of the or avoid contact with oxygen, I think, a carboxylic acid can form. It's not about oxidizing twice. When you oxidize an alcohol, when you oxidize it in I think it's in air without doing a certain procedure, I forgot what it's called, it could form a carboxylic acid. So it's not about different oxidizing agents, it's about how you do it. Okay?
Wasn't this the Jones reagent? It goes from primary alcohol straight to carboxylic acid.
It does because it's stronger. But if you do it, there's a procedure, you probably took it, but I forgot what it's called. You prevent the escape of it, I think, further oxidization, because contact with oxygen. If you prevent that, you could form an aldehyde. But Jones reagent, yes, but Jones reagent it does directly oxidize into carboxylic acid. This is like one, but I'm talking about KMNO4, K2CR207. They're all used all over, but PCC is the most common.
Oh, I think you mean اللي هو إنه limiting it at aldehyde.
Yes,
The procedure, I think it was distillation.
yes,
Yeah.
distillation. Thank you very much.
والله distillation is limiting.
Yes,
You remove it before it further oxidizes.
exactly.
Or you use the PCC من الأول.
If you leave it like that, it's definitely forming carboxylic acid. Because what
If
is
you left the PCC,
no? If you oxidized alcohol with anything, with any oxidizing agent, K2CR207,
okay,
without distillation. Did you say that? I forgot the word. Distillation.
Wait, so when we're gonna put PCC, no need for distillation. It will go for aldehyde and it will stop at aldehyde.
Yes.
But if we use like Jones reagent, we have to do the distillation in order to get aldehyde.
No.
That's what I know. Again,
No.
like-
Distillation, you do it to avoid it oxidizing to carboxylic acid.
Okay.
Most cases, so it's
In everything, if you're oxidizing alcohol and it's going to, I mean, look at the reaction. Alcohol eventually oxidizes to carboxylic acid. But how do you prevent this? You distill the aldehyde
But-
before this
So we
happens.
use PCC هو بيقعد على الكيتون.
I'm actually not sure, but what I know personally is whatever oxidizing agent you use, it's probably going to end up as a carboxylic acid without distillation.
No, PCC is an exception. PCC only gets it to aldehyde.
If you took it like this, then yeah, it's probably correct. PCC, it's different, but I'm talking about K2CR207 and KMNO4.
So PCC no need for distillation with PCC, but with normal oxidation,
Yes.
we have to do a distillation in order to get
Yes.
aldehyde.
Yes.
Distillation.
Also, the aldehydes and ketones in nature, this slide as well, you need to know this. I remember for us, he focused on vanilla and cinnamon.
لا لا ما في
But all of them you need- ما تحتاجه؟
لا بتذكر اني سالته وقتها قال لي لا هيك بتذكر.
لا. For us it was necessary, but I don't remember أصلا it came. I'm not sure if it came أصلا. But he mentioned it, but I remember he highlighted certain ones.
كتير ركز على الفانيلا. Whoa, Dr. Hassan and Dr. Najjar, they mentioned vanilla a lot.
Yeah, vanilla, they mentioned it.
بجوز تجي كسؤال والله في عندك هذا الفانيلا عمل له هذا الرياكشن بس ما بعتقد انه تجي والله.
It never, I don't think it came for us, but I remember him mentioning, no, we need to know vanilla and cinnamon. I'm not sure.
I think Dr. Hassan said they'll bring the picture or they'll say what function in the group or something like that.
really?
I don't know.
No.
If you have the time, I don't think you do. But did you specifically ask him and he said you don't need to know it?
وده سألوا حدا معنا يعني بس
picture.
لا
Picture of the computer.
Then it's different for every batch. I don't know. For us, he said, you have to have an idea of it. I remember vanilla and cinnamon.
واجت بالاخير؟
لا ما جت. يعني I don't know. I don't want you to waste your
خلاص
time.
ما حفظ فانيلا وسينمون يعني
هو if he mentioned vanilla, just look at it. I don't think vanilla is difficult. Just it's basic. It's basic. بس هدول يعني شوي.
وإيثر وأدهم.
Yeah, just have a look at it. You don't have to like waste your time on it. The carbonyl group, we said it's what makes them common. A double bond between a C and an O. Both are sp2 hybridized, trigonal planar geometry. O is more electronegative, polar covalent bonds. I think that's clear. Resonance is possible due to the pi bonds. You know about resonance too. I think it's all repetitive. I just put it in because it was in Dr. Najjar's slides. So for nucleophilic addition reactions, do you have an idea of this? I think you took it before as well, or this is the first time you see it.
No, we took it.
You took it before. So you know how it comes, the nucleophile comes to the carbonyl carbon, and the electrons move to the O, so it becomes negative. We add water, so the H in the water bonds to the O. Clear, صح? Here, do you know why we add acids to catalyze? It speeds it up. How? Because it increases the resonance on this. Not the resonance. It causes a positive bond, so it attracts the nucleophile more.
طب ما resonance بيعمل positive bond؟ positive
It makes the reaction faster. It speeds it up. It's a catalyst.
Why? Because
because C structure too. Yes, it makes the C positive.
But resonance in the normal state without a hydrogen makes
it positive. But imagine if it's a free carbon with positivity. It's just free. It's even stronger. It's even more positive.
Okay, so the rate of resonance is faster than the rate of the reaction. فالرياكشن ما راح يقدر يصير الريزونانس موجود، لازم نثبت الريزونانس يعني لازم
هو تصير بس أبطأ. You get me?
Okay.
Yeah. For here it's faster. That's why it's a catalyst. It's an acid catalyst because it frees the carbon. It makes it more positive, so more attractive to the negative nucleophile. So nucleophiles. Do I have to go through nucleophiles? Do you know the poor leaving groups and good leaving groups? You just have to know. It's like such as the conjugate base of weak acids and the conjugate base of strong acids.
Conjugate base for weak acid like Cn minus?
Base for weak Cn. No.
Yeah, Cn minus is a conjugate base for a weak acid of a weak acid.
Oh yeah, صح. Yes. Okay, so aldehydes versus ketones. Generally, ketones are less reactive than aldehydes due to the steric hindrance at the carbonyl group. The stability of the carbocation. We said that's because they have two C's, so it's very stable in general. Okay. Second, alkyl group stabilizes the carbocation, making it less reactive. Okay. This is the trick. It's the same idea I just said. It's the alkyl group in the ketone.
والستيريك هندرنس انه في two bulky groups على الكيتون.
Yes. Yes. Exactly. This is my little secret. I don't know if you've ever come across the reaction summaries in the book. Have you seen it? This is my secret. No one used it, and no one I knew used it, but honestly, it was a lifesaver. I didn't include all the reactions. You need to go through them through Dr. Najjar's slides. But when you want to revise all the reactions, revise them through the reaction summaries. Literally everything you need to know. Yani, all the reactions you need to know from each chapter, especially for the final, because you'll see there's so many reactions to know. The reaction summaries, they're all in one page. You just read through them and you make sure you know each one. It just helps you so much. It saves your life, literally, and saves you so much time because you need that time. you know, so you can revise more dense information. The reactions just in one place, just read them through. So here we know the preparation of aldehydes and ketones, the oxidation of alcohols, we explained these, we talked about this. Hydration of alkynes, just go through them, just memorize all of these. Further Kraft's acylation, we mentioned it briefly. So the reactions of aldehydes and ketones, formation of and hydrolysis of acetals, this is very important. The hemiacetals and the acetals from an alcohol and a carbonyl, it's very, very important, this reaction. It comes multiple times. I think we see so many questions on this, the hemiacetal and the acetal. Grignard reagents, I think Malak explained this, right? I remember she explained this. Formation of cyanohydrins, also go through it. It's also in the slides. Go through it in the slides and then review it through the reaction summary. Yes?
What kind of questions will we get about the acetals and hemiacetals?
Don't remember, but usually they give you a certain alcohol and a certain carbonyl. I don't remember.
Yeah, what was the product? What is the agent?
Yes, usually, yeah, they sometimes give you photos of the products. Okay, that was one of the forms of questions. Malak, how do hemiacetal and acetal questions come in the exam?
They usually give you the reaction with the reagents, and then they show you the actual product, if it's hemiacetal or acetal, basically. Isn't it like a two-step process to get acetal?
Yes.
Yeah,
2 steps.
so check the reagent that they give you, basically. Based on the reagents, you can see why.
ما نسأل
Yeah.
Based on the reagents, that's
Excuse me? Don't finish.
we need some
Just a
time.
few minutes.
Sorry?
We need some time, please.
No, cannot please. Time already finished now.
Yeah, we're gonna leave now. And I was just explaining the reaction summaries. And just go through them. Go through the reactions. It will save your life. I'm done, Aslan. It's just these reactions. Apparently, we don't have time to go through them, but these are. This is the key. Go through it in details. It will be in details in Dr. Najjar's class and Dr. Najjar's slides, but the reaction summary saves your life. The last slide.
You know, alcohol والcarbon اللي فيها OH, it has a double bond with the carbon next to it. يعني double bond and
Okay.
Okay. That's it.
Yeah.
We don't have time.
We're supposed to, but he's kicking us out.
Yeah.
I guess we have to finish.
Okay. That's it.
Unless you're done? Alright.
Bravo.
Well, that's it.